got that far in literature. When you look out in the books, I was impressed with Borders. They had a nice science. I found an old Emilio Sergei book about stuff that was discovered. He was another. This is his chart, actually. He's the one they call it a Sergei chart. Cal Berkeley again. Read that history. Look in the back of name, because you can't read the whole book.
The original one is still on the wall, and it's up there in individual little squares, pinned.
The whole thing in the Berkeley lab.
Yeah, it's
Al
an
Gerson's
amazing
office. So I'm just saying, there's stuff out there. We need to inspire kids. You know, we don't need to teach them what's already been taught. I tell them, I'm teaching you something new. Let me see what else I can do. I don't think those elementary teachers are coming back, are they? I'll just give you ideas. I don't know if you've been, I'll tell you, with Pismo Beach, I'm a recycler. I went out and I did a test. Forget Pismo, I'm from Korea. Remember the Michael Jackson trial? I went out the night of the trial. I got 1,000 water bottles from those reporters in one night. $41 of recycling. All this goes to landfill out there. Pismo Beach, the tide washes in and washes all that garbage out there. This is something we need to teach the kids. At the space camp, I'm recycling. We would figure out how much of we saved by recycling to mail a can up to the space station by mass and all that. And here's the director throwing her stuff in the trash because she didn't even want to walk out the recycle bin was. This is important stuff. It's really important. So my point is, with me being a cheapskate and a recycler, National Geographics are still out there. When you see those whole stacks, look for the space ones. These are the 3Ds. Remember the 3D glasses ones? 15 cents for the whole thing. And they're still with the glasses in them. There's cool. I'm at a NASA Ames conference now. My friend Joel Hagen's the one that did the colorization of these things. So this stuff's out there.
I've got a question. That was pretty interesting to get on board, and it's almost getting to know them. Did I hear you correctly when you said all of what you condensed together is not written?
Not in like one place.
Not in one
Even when you look at how these guys, who are the premier ones, do their chart, they list the quarks are all the same size. They're not the same. You know, my thing is descriptive, and I use color. I use drawings. If I can show you real quick what I did with, have you ever heard of Oliver Sacks? When I did my periodic table, I went to college in Marin. Robin Williams lives up there, right? Williams was one of my inspirational ones. You know, I struggled with science, man. The math and all that, you know, not having been to school in 10, 12 years after that. Awakenings, inspiration. If you remember the Parkinson's L-DOPA story. Another one is Lorenzo's oil. I don't know if you guys are chemists, but have you ever seen Lorenzo's oil? I wanted to get a copy of that guy's paperclip thing he was doing. Nick Nolte's in the library. No chemistry experience. He's carbon chains out of paper clips. Well, that's what fats are. They do these 2 carbon betas, they call them, and that's the way fats are made. If you ever seen like C14, C16, stearate, and all those are all even numbers of 2s. So here's Nolte doing it with paper clips. And I'm like, there's ways to teach this out there in a fun way that the kids will get it and remember it. So with Ollie, I call him Ollie now, you know, we correspond all the time. He's on 60 Minutes wearing a periodic table t-shirt, and Robin Williams comes up and starts giving him noogies. I'm like, wow, these guys are cool, you know? And so I sent him a periodic table, you know. I go, oh, I do a t-shirt, you know. He sent me a check. He goes, send me 2 of them, you know. So we started corresponding. L-DOPA. This is one I've been working on for a while, and I kind of finalized it, because if I ask you to draw the L-DOPA molecule, I'm a chemist, okay, and double bond, you know, I think there's a ring in there somewhere, right? And it's from tyrosine. This is what I'm focusing on now, are amino acids. Well, let me show you what L-DOPA. I'm down in Santa Maria. 10% of our population is a Mexican national. So L-DOPA to me is L-DOPA. Right? So I'm looking at the molecule, and I'm doing it strictly from memory now. Okay, I know there's a ring up there. And I know it runs off kind of this way, and down, and then down, and I know this is a nitrogen. This is the way it is, because usually I don't draw hydrogens, but I'm going to do it anyway. So I know there's nitrogens that give them like little hands there. And being there's 2 oxygens up here, so it gives them like a little antenna. And the benzene ring, now whenever I see a benzene, these are eyes to me, and that's a mouth. So I kind of give them a little cross-eyed look here. And then I'll put a little sombrero on him. Looks good when you do it in color anyway, so if I erase El Dopa here, you can see that by drawing the cartoon, you can remember how the molecule looks. The benzene ring, there's 3 little double things in there, but now it's like a cross-eyed with oxygen antlers. It gives life to it. So what I came up with after that was DNA. If I asked you to draw the chemical structure of DNA, can anybody do it? Well, that's the big picture. I'm talking from a chemical point of view.
Yeah, they're on the table in front, green blue. I think.
I don't want to waste time. I didn't even get to the good stuff. See, I got to do the introductory.
It's 4 to 12, so the elementary folks are going to be coming in pretty soon.
Which are gas.
Quick, do the DNA. Whatever.
Sounds like gas, unless it's a hole in the line. Okay, so DNA, there's 3 parts. Nucleic acid, the ribose, and the phosphate backbone, they call it, right? So again, I'm looking at the ribose. I got a little dog named, stop, Susan Balloon, whoa, careful. Susan Balloon, so stop. My latest little Siberian Husky puppy, he's 4 months old, man. I take him into the old folks' home, he's so good. I named him RNA. DNA, right? Well, RNA is the real stuff. This is another one of those contradiction things. DNA. RNA is the cool stuff.
Yes.
I went to a conference and the guy was saying, life started with RNA. DNA can't do anything. RNA is the back thing, right? Anyway, the R stands for ribose, right? Ribose is just that home plate kind of thing going on there. Now up here, put a kick in the elbow whenever there's another carbon there. That one's straight. This holds the nucleic acid, which I won't go into. Where's the oxygen? Because deoxy, see this confuses kids. DNA, deoxy, that's almost as long as ribo. So why confuse the definition with deoxy when all it means is something's not there? We make the name longer when the oxygen's not there. Does that make more sense? Condensed. Point is, here is where the oxygen is. So it's either, that's the whole difference between RNA and DNA. But look at the difference. RNA can move DNA, it can copy it, it can make enzymes, everything else. DNA is just like, blueprint. Anybody ever build a house? DNA is the architect. Well, it's on the drawing. And you're like, yeah, but the property line is here. If you build a fence within 5 feet, come back, we did that once. We had to tear the whole corner of this house off, just shade the edge because it was too close to the property line. But that's the architect. DNA. Come down, can't you read it? The RNA, man, really has the power to go through and go, this doesn't fit this one, man. Change it. It should be a binding or Whole point is, I'm looking at this, right? Whenever I see an oxygen circle, make it friendly. This is Ricky ribose. Nucleic acid, the sugar, goes down to another one there, right? The phosphorus now, you remember phosphate? How many oxygen bonds? 1, 2, 3. This is why I really need the colors, because I call them phosphoflowers. There's 4 of these guys going off there. One of the oxygens will go to the next one up there, one will go down there, right? Kids will draw this stuff. And they'll draw it better than you, better than me anyway. This is DNA. This will go down to another one, this will go up to another one. So the next one down is ruby ribose. I got 4 of them because there's 4 bases. Ricky and Ruby will go out because that's a triple hydrogen bond one. The other one's T, A, and G, and C. The others are 2. So Ricky and Ruby are the only ones that will go out. It gets more complex.